This lesson is about solving two-step equations. So there are a few things to remember with this as well. Your goal is to have all variables on one side of the equation and numbers on the other side. We're going to use opposite or inverse operations to isolate the variable. For example, if a number is added to the variable, you should subtract that number. And then if you do something to one side of the equation, you must always do the same thing to the other side. The easiest way to work with solving equations is to work GEMDAS backwards. So yes, that means you're doing SAD-MAG. First thing we're going to do is look at a model. When we're modeling equations, when we have two x's like this, what that really means is we have 2 times x. That's the way we write 2 x's. Minus 2 equals, there are 4 on the other side. Now, to solve this particular equation, I'm going to show my steps down here while I use the model to solve it. So how do I get rid of a minus 2? With a plus 2. But if I do it over there, I also have to do it over here. So essentially what I've done is I've added 2 to both sides. Now, why did I do that step first? Well, that's because I want my x's alone. And when I add those, these go away. I don't have any negatives over here, so these get to stay. So that's why we say you're doing GEMDAS backwards, because you got rid of addition and subtraction before you got rid of multiplication and division. Try to make that look more like a G. So this went away, just like it did up here, and I ended up with 2 x's on one side and 6 numbers on the other. Next, we should be dividing these guys up for the x's, because each x has to represent the same amount. So when I circle this and divide it into 2 groups, that means I should also be circling this and dividing it into 2 groups, which means each x gets 3. The way we would show that algebraically is I divided this by 2, because to undo multiplication, you do division. This went away, and I just had an x equal to 3. Let's try another one. First thing I'm going to do is write my equation. I have 3x plus 3 equals 6. And again, I'm going to show my steps down here as I work so that you can see why we do things the way that we do. First thing that I have to do is get rid of these 3. So you can either do that by adding negatives, or you could do what we call the cross-off method. And I'll explain that one in just a second. So on this one, when I subtract 3, or when I add 3 negatives, these guys go away. Remember that adding 3 negatives is the same thing as subtracting, because you add the opposite. These went away, and I had 3 x's left over, and over there I had 3. Well, if you think about it, 6 positives and 3 negatives make 3 positives. So now I'm going to divide my groups up. Sorry, that circle was a little bad. I should have 3 groups, which means each of these x's gets 1. It's the same thing as showing divide by 3, and x equals 1. So again, the reason we get rid of the add and subtract first is because we have to get rid of these singles so that the x's are alone so that we can divide them up. On the next one, I need to get rid of a negative 2. Oops, I forgot to show you the other method. Sorry about that. Okay, there is another method called the cross-off method, which we've kind of talked about a little bit before in class. Oops. Try that again. Because you have 3 positives on this side, what you can really do is remove them. That's the same thing as subtracting. All we did is we removed 3 positives. But you have to be able to do that over on this side as well. Since I have 3 positives over here, I can do that. So again, if I take 3 positives off this side, I have to be able to take 3 positives off this side to keep that balance equaled out. And that's the same thing as showing minus 3 on each side. Then you still have your 3 to divide up by your 3. On the next one, again, we can do this either way. Well, let's go ahead and model first. So we have 5x minus 2 equals negative 7. I have enough negatives on both sides that if I take off this negative and this negative, doesn't make a difference. It's the same thing. Take off this negative, take off this negative, doesn't make a difference. Same thing. So what I've done, that looks really bad. Let me erase that. There you go. Is I've taken off 2 negatives, which is the same thing, add the opposite, is adding 2. That's why we always work with inverse operations when we're doing the algebraic part of it, because otherwise it can get a little bit messy. So this went away, and we had 5x left with negative 5. As you can see in our model, we have 5x and negative 5. So now I'm going to draw my circle. There's 5 x's, so I need 5 groups, which means over here, I should also have 5 groups. 3, 4, 5. Which means each x should equal negative 1. So what I did is I divided it into 5 groups. So each x got negative 1. So now we're just going to be showing our steps. Okay, so we're just going to be showing our steps here. Sometimes I like to draw a line down through the equal sign to make sure I can keep everything separate. Now remember that this represents the x's and this represents the singles. I was always supposed to get rid of the singles first, so then I could divide up my x's. So to get rid of an add 4, I subtract 4. Positive and negative is 0. I have 3x left, and that equals 16, and negative 4 is positive 12. Now I can divide my groups, and I get that x is equal to 4. To check, I'm going to write my original problem. I'm going to plug in my answer, and then I just need to follow order of operations. Multiplication comes before addition, so 12 plus 4, and 12 plus 4 is 16. So did it work? Yes. Again, I'm going to draw my line down through. I need to get rid of these singles first. So how do I get rid of a minus 5? With a plus 5. So positive and negative is nothing. 2a equals 17 plus 5 is 22. Now I need to divide into 2 groups, which gives me a equals negative 11. Let's plug it back in to double check. Two times negative 11 is negative 22. Remember to add the opposite. Negative 22 and negative 5. Oops, see? That is why a check is a good idea, because I just made a big mistake. And notice I checked it, so I caught it. 22 divided by 2 is a positive 11. I don't know what I was thinking. So let's try that again. 2 times 11 is 22. And when I do 22 minus 5, that's where my 17 comes from. So that's just a prime example of why doing a check is such a good idea. Okay? This one looks a little bit different because we have a minus 2x. But we're still going to do the same thing. This guy right here is a positive, so how do we get rid of a positive? With a negative. So be very careful when you do this one because that negative comes with that 2. That minus sign, you really have to kind of think about it as a negative. And then you've got positive 3 and negative 17, which gives you negative 14. All right, so on that, this is one of those tricky ones. Remember when we had x divided by negative 2 and we had to multiply by negative 2 to undo it? Or we had negative 2x and we had to divide by negative 2 to undo it because two negatives made a positive? It's the same thing here. All it is we're doing it in two separate steps. So negative 2 divided by negative 2 makes positive 1, which is what we want, just 1x. Negative 14 divided by negative 2 is positive 7. And just to check, because this one was tricky, we're going to go back and plug it in. 17 minus 2 times 7 equals 3. 2 times 7 is 14. 17 minus 14 is 3. So did it work? Yes, it did. All right, so check the next pages in your booklet and you'll find your homework.